We'd like to be able to define trigonometric functions for angles beyond just acute angles, angles that are less than 90 degrees. And so we need a way to extend our definition. And instead of defining them based on by triangle per se, but doing it based on a point. So this is how we do it. We're going to look at a point. We're going to call it P, which has coordinates x, y. And we're going to look at a point on a terminal side of an angle theta in standard position. And from that point, we're going to let r equal the square root of x squared plus y squared, where x and y are the coordinates of that point. And this is the distance from the origin to the point. Let me go ahead and draw a picture so we can see what exactly is happening here. So we have just axes, okay? And when you measure an angle could, it could go around, to any spot we want, and you end up with, okay, this terminal side. And we're saying take a point on that terminal side and call it xy. And then we want to define this distance right here. We're going to call that r, okay? And it just so happens that that is equal to, if you create a right triangle out of this, okay, then you can think of kind of this as the x and this is the y, and then the Pythagorean theorem, x squared plus y squared equals this distance r squared, and so you get r is equal to the square root of x squared plus y squared. And you can see that I've now created this triangle, and so in that way I could use the definitions of my trigonometric functions for this triangle using x, y, and r, okay, where x would be the adjacent side to the angle, y would be opposite the angle, and r would be the hypotenuse. And that gives us these definitions here. Okay, sine is y over r, or if you look at this, we see opposite over hypotenuse. And cosine of theta is x over r. In this picture, we see x adjacent over hypotenuse. We can continue in that manner with each of our functions. Tangent is opposite over adjacent, or y over x, okay, and so on. And of course, you can see that we can't divide by 0, and so this should be y not equal to 0, and y not equal to 0. We can't divide by 0, and so if our point on the terminal side of an angle is like on an axis, then we're going to have some trigonometric functions that just are not defined; they're undefined. So this is how we define the trigonometric functions for any angle. Okay, we draw the angle in standard position, we take a point on the terminal side, and then these ratios will be our trigonometric functions.